Number 40, we're taking a lot of information that we know about how to find congruent triangles like side, 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 or side angle side, or hypotenuse leg, and trying to write a two-column proof with it. So first of all, make sure you're setting up your proof. We've got a two-column proof here, statements and reasons. I started filling in some of the information. We've really got three things that are given to us, and so I put those over here. CR is congruent to CS. That's given to us. QC, whoops, forgot to add my lines, I should do that. QC and CR are perpendicular, that's given to us. QC is also perpendicular to CS, that's given to us. And you notice I started numbering these, 1, 2, I didn't put a 3 here yet, not just yet, I could have, but I'll show you why in a second. And I didn't number this yet because I don't know if it's going to be my 5th or 6th or 7th statement or whatever else, but this is my proof statement at the end. That is what I am trying to eventually get to and say I know is true because I've proven it all up top. Okay, this is the diagram that goes with it in case we want to reference that. CR is congruent to CS. Okay, so those are the two bottom line segments of the triangles that are marked congruent in the diagram, and that's given to us. The reason I left a space in here is because QC being perpendicular to CR, so let's look at what we're talking about here. Here is QC perpendicular to QR. That tells us that this angle in here is a right angle, and it is marked that way on the diagram. So really I should have another statement here that says angle QCR is right. Angle, oops, QCR is a right angle. I'll list that as my third statement, and so the reason is that is the definition of perpendicular lines. If these two lines are perpendicular, it means the angle in between them is right. Okay, the same thing is true about QC being perpendicular to QS. Here's QC, and I'm sorry, CS. Those two lines are perpendicular, and again, this angle included is right. That's angle QCS. So angle QCS is right. Okay, so that means that was 4 and that was 4 given to us, and because we've got those perpendicular angles, I can say the fifth statement, QCS is right, because that is also the definition of perpendicular lines. Okay, so since I've got this angle being right and this angle being right, I can say that they are congruent. That's going to be my 6th step. Angle QCR, which I said is right, must be congruent to angle QCS, which we said is right, because that's the definition of right angles. And so really at this point, when we're looking at the triangles that we're trying to prove are congruent, we've got a side that we know is congruent up here, and we've got an angle that we know is congruent right here. We need a third side. And I can say, because QC is the same side in both of these triangles, that line segment QC is congruent to itself, line segment QC. That is the reflexive property of congruence. And so that is the third thing that I needed. I've got a side, I've got an angle, and I've got another side that are all congruent in both triangles. So I can finally say that that this statement is true. Triangle QCR is congruent to triangle QCS because of the side, angle, side congruence postulate. That is our two-column proof, proving that those two triangles are true based on the given information.